Hi, it's Dallas here. This presentation will see me addressing the issue of coal seam mining, also known as fracking, and its effects on underground water supply, an issue currently affecting southwest Western Australia at the moment. Fracking is a method of extracting natural gas trapped between seams of coal and shale rock that run below the Earth's surface. A borehole, lined with steel and concrete, is drilled vertically into the ground until the shale or coal seam is reached. At this point, the borehole changes direction and follows the shale or coal seam horizontally. Explosives are deployed at the end of the borehole to create cracks in the shale or coal. A water, chemical and sand mix is then pumped into the borehole to keep the cracks open and help in the extraction of the gas. Any remaining water is removed from the hole to make way for the gas, which finds its way to the surface. Because the issue of fracking is such a current debate in my community, information sessions are being held by the local council together with mining companies to discuss the future of local fracking in the light of protests being staged in the area. This is the reason I chose to investigate fracking. I originally proposed the question, how does fracking use and affect water? How is water polluted? How is polluted water disposed of? And what measures does the Western Australian Government have in place to make fracking a safe venture? Google search engine has been the first point on my way to gathering information. Much of what turns up on Google under the word fracking is protest pages and news. To find information from mining companies, I had to use more formal names for fracking. Many of the articles quoted professionals who contributed in helping the article writer to form an opinion. Curtin Library had much peer-reviewed content from these authors. In addition, gleaning the references in these articles led to more quality content. The only research issue I had been faced with in this topic of inquiry is finding information from an Australian context, as fracking is relatively new here. Here are some of my key findings. The water issues that surround fracking are the depletion of underground aquifers and the pollution of ground and surface waters from unnatural chemicals, naturally occurring heavy metals, and/or gas condensates. One gas well used an average 20 million litres of clean water, either extracted from the ground or collected from lakes or dams. In Australia, up to 45 toxic and non-toxic chemicals are mixed with water for a range of purposes in the extraction of gas. This mixture is known as fracturing fluid. Of the average 15 million litres of water used in the fracturing process, 85 to 90% is lost underground. As of 2014, 15 wells have been drilled and 7 have been hydraulically fractured in Western Australia. I will still need to investigate the research and resulting resolutions that have been conducted on past occurrences of water pollution through fracking, the factors and risks involved of future events occurring, especially in relation to southwest Western Australia and the measures being proposed to combat the risks, and the government fracking relating to the policies that have in place to prevent adverse effects for its people reliant on ground and surface water due to fracking. The first content descriptor on this table could see students investigate a realistic problem of a local dam or river, present them with a few options aside from fracking, such as a nearby sewage plant or a market garden that uses fertilisers. An investigation could then be set up to determine how each activity could contribute to the contamination and which would be the most likely suspect. The second content descriptor could see students looking at the process of fracking. With help, the students could devise a list of problems that could occur. Predictions could then be made about the likelihood of the problems, and also the result of the problem, with investigation that follows. At the end of the investigation, the predictions could be compared to the findings. The third content descriptor is more about the investigation process. This could see students collaborate their ideas about the most effective way of researching the problems posed under the last two content descriptors. A plan could be drawn up and followed during the investigation. The plan can be reviewed briefly along the way and in depth at the end of the investigation. Thank you for listening to this presentation.